Hey, this is Mr. Krenz, and in this video I'm going to go through the average rate of change. I'll teach you a little bit about that. So the average rate of change, the big idea behind this is that things change all the time. It's just life. And not even do things change, but the rate at which things change also changes a lot. So you might think about if you're driving down the highway, your rate of change then is how far you're going, which is your speed, but you don't go the same speed the entire time on the highway. Sometimes you have to speed up, sometimes you slow down, the speed limit changes, and so the rate at which you change is changing constantly. And so it's often, since it changes so much, it's going to be much more useful to talk about the average rate of change instead of the instantaneous, the exact rates of change. It also lets us avoid doing some calculus. Let's get started here. Let's talk a little bit about what this means. Now, averages in general, an average is just you take the sum and you divide it by the total. So if you're thinking about like, I have a soccer game tonight, so you think about the average number of goals scored, average number of goals I've scored per game. You take the total number of goals, the sum of the goals, and you divide it by the total number of games I have. So you take like say 14 goals divided by 10 games, you get an average of 1.4 goals per game. Now, if it's an average rate of change, what you're going to do is take the change in the y's, the outputs. Remember, we're thinking about these guys as outputs, and divide it by the change in the x's, which are our inputs. Okay? You'll often see this notation. I'm going to use this a little bit in this video. There's a triangle y. It's pronounced delta y over delta x. So take our change in y's and divide it by change in our x's. All right, a few examples. First thing is I'm given a function, f of x equals x squared plus 3, and I want to calculate the average rate of change of that function on a specified interval. So let's look at that language a little bit, break that down. So my function right here describes the relationship between the inputs and the outputs, and I'm looking at that function only in a very specific part of it. This is all x values here, that's an interval, so it goes from the smallest x being 1 to the biggest x being 4. Okay. So now when I get into calculating the average rate of change of this function f on this interval, we're looking at, we need to find the change in the y's and the change in the x's. For the y values, I don't have a y in my equation, but when we look at a function like f of x, f is the output, so we have to, the f of x is the y value. So, since y is equal to f of x, we'll be looking for the change in y's, and that'd be the same thing as the change in f of x. Okay, so find the change in the y's, look at the change in the outputs of the function. Okay. So, to get through this one, f of x equals x squared plus 3. If I'm going to find the change in y, put that down here, change in y over change in x, that I ultimately need to find. The change in y is I'm going to need to find the change in the output values. So let's see, I'll need to find f of 1, since 1 is the smallest value, and I'll need to find f of 4, since 4 is the biggest x value. This interval, 1 to 4, is an interval of x values. It's not an ordered pair. All right, f of 1, substitute in, I have 1 squared plus 3, which would give me 4. To find f of 4, I substitute 4 in for x. So you have 4 squared plus 3. 4 squared is 16, and 16 plus 3 give me 19. So what that means is if I go down here, the change in the y values would be 19 minus 4. The change in the x values, I say, well, I have 4 and I have 1. I want to know the difference in them, so I'll subtract those guys to get 3. So I have 4 minus 1 right here. Let's move that whole thing over. And 19 minus 4 gives me 15. 4 minus 1 gives me 3. And 15 divided by 3 gives me 5. Therefore, the average rate of change of the function f on the interval from 1 to 4 is 5. If we went that rate the whole time, we'd start and end at the same place. Example number 2. Find the average rate of change of g of x is equal to 3x plus 7 on the interval from negative 2 to 4. Looking back at what we did in the last one, we know we need to find the change in y's, and we need to divide that by the change in x's. So what I'm going to do is I need to find the change in y's. The y's are my g values, and to find the values of g of x, I plug in the spots in my intervals, negative 2 and positive 4. But I need to find g of 4. I will then subtract g of negative 2, and I'll divide that by the change in the y's, and the change in the y's is 4 minus 2. Okay. And what this gives you right here is, in essence, a formula for calculating average rate of change if you're given a function. You take the outputs, subtract them on the top, you take the inputs and subtract them on the bottom. Now it is very important you keep the order of these the same. So I have the 4 here, so then the 4 will be there. The oops, and looks like I actually missed a negative here. Glad I caught that. So right there, it should be g of negative 2. Keep these in the same order. To evaluate this expression, I need to find g of 4 and g of negative 2. So g of 4 would be 3 times 4 plus 7. 3 times 4 is 12, and 12 plus 7 is 19. Find g of negative 2, which should be 3 times negative 2 plus 7. 3 times negative 2 is negative 6, and negative 6 plus 7 is going to give me a positive 1. And so plugging those in, g of negative 4 is 19, g of negative 2 is a positive 1. 4 minus a negative 2 would be a positive 6. That gives me 18 over 6, or just 3. So the average rate of change of the function g is just 3. And if you think about that a little bit, if you look back at what the original equation was, this is a linear equation, meaning it's a straight line. Think about it, the average rate of change of a straight line, well, it changes at the same rate. It's straight the entire time. So the average rate of change would be the slope, and the slope here was 3. And that's precisely what we got for the average rate of change. Okay. So basically, you can use the formula right there we kind of developed. Take the change in y's divided by the change in x's. Okay. 2 more examples, and they look a little bit different. This time we're given a graph, so a function that's defined by a graph. So I have the average rate of change of h of x on the interval from negative 4 to negative 5. Idea is still exactly the same. We need to find the change in the y's and divide it by the change in the x values. Now, from the interval from negative 4 to 5, that means these things are both x values. So if I go to negative 4, I see that I have the point that's actually the x-intercept right there. And then if I find where x is 5 in this graph, it intersects the graph right here. Okay? So those are my 2 different points here. Now I want to find what is the change in the y values. And well, the y values made it this high up. So the y values went up 3. Okay? The x values, well, the x values went farther. They changed this distance right here. That's how far you'd have to go horizontally. And you can count that. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So my average rate of change is 3 over 9, or if I simplify that down, I get 1/3. Okay? Still calculating the change in y divided by the change in x. In the graph, though, we can do this visually. Okay. Similar setup here. I have a slightly different interval from negative 1 to 2, and I have a different function, h of x. This one is actually an exponential in this case. All right, same setup. I need to find the change in y divided by the change in x. So let's identify the points on the graph. When x is negative 1, our point is right here. And when I have x is positive 2, I get the point right up here. Okay. So my change in the y value is how much I have to go up. And oops. Be right here. So if I count that, it's 1, 2, 3, and then a half. So 3.5. I count how far I have to go over. That'd be this length right here, which is 1, 2, 3. So I end up with 3.5 divided by 3. All right, for this you could just pull your calculator out. Let me do that. .5 divided by 3 gives me approximately 1.17. Okay. So average rate of change, all you're doing is finding the average rate at which something is changing. To do that, you're going to find the change in y divided by the change in x. So that's going to be the change in the outputs divided by the change in the inputs. For graphs, you can count that visually. Look at the graph, identify the points from the interval, and then identify the change in y's, which is also often known as the rise, and the change in x's, which is often known as the run. Right? If you're given, an equation, similar setup, you're going to find the change in y divided by the change in x, but this time you're going to have to use the function notation. So evaluate the functions, subtract the differences of the outputs and the inputs, and you end up with your answer.